Hi, this is King of Review. If B is a square matrix of order 2 satisfying B equals P times A times P inverse, find B cubed. And we're given matrix A and matrix P. So we want to find B cubed. Well, this is the same thing as B times B times B. And we're told what B is here. B is equal to P times A times P inverse. So we're multiplying that 3 times. So we have P, A, P inverse, P, A, P inverse, and one more, P, A, P inverse. So before we go on, I want to remind you that if we have matrix A times its inverse, A inverse, this is going to equal the identity matrix. Now, if you remember, the identity matrix has 1s in the main diagonal and 0s elsewhere. One feature of the identity matrix is that if you multiply a matrix times the identity matrix, the product is the original matrix. You can also have I times A, and this will equal A. So I want you to keep this information in mind when we're solving this problem. So let's look at our problem here. We have B cubed written out here. Now, what I want you to pay attention to is this rule here. If we have a matrix times its inverse, it will equal the identity matrix. So where do we see that here? Well, we have P inverse times P. So that's going to equal the identity matrix there. And we have P inverse times P here. So that's going to equal the identity matrix. And looking over here, if we have a matrix times an identity matrix, it equals the original matrix here. So these get canceled out, and what are we left with? Well, we have B cubed. That's equal to, well, we have a P here, so P. And how many A's do we have? We have 1, 2, 3 A's, so that's A cubed. And then we have this P inverse on the end. So B cubed is equal to P times A cubed times P inverse. So now what we need to do is figure out what A cubed and P inverse are. We already know what P is. That was given to us here. So let's start with A cubed. So A cubed, this is A times itself 3 times. So we have 1, 2, 0, negative 2. That's matrix A, and we're multiplying this out 3 times. Okay, so what does this equal? Well, let's first multiply these together. So when we multiply those, we get 1, 0, negative 2, and 4. And then we still have this last matrix A here. And now let's find the product here. So when we multiply these out, we get 1, 0, 6, and negative 8. So now we know this value here. Now let's find P inverse. Now if we have matrix A as A, B, C, D, A inverse, this is equal to 1 over the determinant. To find the determinant, we take the product of the entries in the main diagonal, so AD, and we subtract the product of the entries in the other diagonal, CB. So 1 over the determinant times the matrix. Now A and D will switch places, So we have a D and an A here. And then we have negative B and negative C. So this is how we find the inverse. So let's apply that here. We're taking the inverse of P. 1, 1, 1, and 2. So what is this? Well, we have 1 over the determinant. So we'll start by taking the product of the entries on the main diagonal, 1 times 2, minus the product of the entries on the other diagonal, which is 1 times 1. And then we're multiplying this by A and D switch positions. So now we have a 2 and a 1 here. And then we take the negative values of the other entries. So what does this equal to? When we multiply this out, we get 1 over, and then we have 1 times 2, which is 2, minus 1, that's 1. So 1 over 1 is equal to 1. So P inverse is 2, negative 1, and 1. So now we know this value. So B cubed is equal to, so P, that's 1, 1, 1, 2. Then we have A cubed. We figured that out here. So that is 1, 6, 0, negative 8. And then we have P inverse, which we figured out here. That's 2, negative 1, and 1. So let's multiply these out. We'll start by multiplying these two together. When we multiply those out, we get 1, 1, negative 2, and negative 10. And then we're multiplying this by P inverse. And we'll take the product of these. And when we multiply this out, we get 4, 12, negative 3, and negative 11. So this is our final answer here, and that's letter C. Thanks for watching.